In this video, I'm going to go over examples 3 and 4 from the lesson that you tried on your own, hopefully. And this one has 3 different simple statements making up this particular overall statement here. And of course, that gives you many different possible combinations for truth values. And so I have P, Q, and R labeled out here so that you can see every possible combination of truth and false with these 3 variables. The textbook does show a few methods about shortcuts that could be taken to kind of make this initial thing, but you kind of get the hang of it after you've done enough truth tables and setting them up when you look and see, okay, well, how many original simple statements do I have, whether you're negating them or whatever have you. And then, from there, you kind of get used to making that first part really quickly. Now, I'm looking to do the intersection of P and Q unioned with R. So if I go through this process, the first thing I have to do is figure out what the intersection of P and Q's truth table is. So that's the first one I come up with and I start doing. And again, I'm looking at these 2 columns over here, P and Q. And again, when I look at these, for this statement, for an AND statement or an intersection statement to be true, both parts have to be true at the same time. If one of them is false or both of them are false, it's false. So as you can see here, the truth values here are both true, so that makes it true. Same thing for this. For the rest of them, because you have at least one of them being false, the rest of them are all false. So that's where you get to this point. So I got this first part, and now I want to union this with R, which happens to be right next to this. So it doesn't matter, the order, because again, just like intersection, union, there is some commutativity around it. I can reverse the statement. There are other connectives that doesn't happen with, but this one it does. So now I could go right to the answer, which basically says, okay, if I look at these 2 columns, as long as one of the statements are true in these 2 columns, the overall answer is true. So this is true. Since this is true, this is true. Since this one's true, this is true. I have 2 falses, so that's the only instance where it's going to be false. And here it's going to be true. Here it's going to be false again. Here it's going to be true. And here it's going to be false. And that would be the truth table for this. In the next example you had, there's a little bit more to it. There's a lot more intermediate steps you have to take. And using the alternate, and that's why they show that initial method, because it does save on space. Use it to make sure you're leaving plenty of room between them, and that you are looking at the right columns at given times. Again, I just find from my experience in teaching logic courses like this in the past that a lot of students, when they try to use the method that the book shows you at first, they tend to mix up a lot of stuff and end up reading the wrong columns for things and end up making mistakes along the way. So I find it just better to just kind of do it statement by statement. So here I have not P and not Q, or not R. So there's a lot of, negation statements going on with this, and that sometimes leads to some difficulty. And even when I started setting up this table, I forgot to put not Q in there, because I see Q, but not Q does play a role in this. So when I look at P and not Q, which is the very first thing I should try to figure out, I do need to know what not Q is. And basically not Q, it's pretty easy, because I just do the opposite of whatever Q was. So whatever says true in Q is false in not Q, and vice versa. And now I look at this column here and this red column I came up with, and it's an AND statement. The only time it's going to be true is if both of them are true at the same time. Any other statement, if one or both are false, the whole thing's false. So false, false, true and true, that's going to be a true one, same with this one. But the rest have at least one false in them, so the rest are going to be false. But this isn't what I'm looking for. I'm looking for the negation of this entire statement. So that's what the next one is, just me negating this one. So I'm just looking at this column right now. The rest of it doesn't really concern me right now, the rest of the table. Just this column. I just want to do not this. So again, I'm just going to reverse everything here. Everything that's false becomes true. Everything that's true becomes false. So true, true, false, false, true, 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 true. So now I have this entire left side done. I got to figure out what not R is, which isn't too hard because R, I have these values here, and all not R is going to be is just the opposite of these. So not R is just going to be me taking the opposite of each one of these statements. So instead of true, false, it's going to be false, true, false, true, false, true, false, true. And when you use this alternate method, which is the one I recommend you using, it's always good to try to have the whenever you get into the final statement, because now the only thing I have to take care of is this OR statement here. It's good to have the left-hand and right-hand statements together so you can just look at the two columns, because this OR statement for the final statement just means that, okay, when I look at these two columns, as long as one of them is true, the whole thing's true. The only time it's going to be false is when both are false. So I have one true statement here, two true statements, both are false, one true statement, one true statement, two true statements, one true statement, and two true statements. And therefore there is the truth table of that statement, which means the only time that statement is going to be false is if you have the original statements P being true, Q being false, and R being true. So that's the end of this video. If you have any additional questions, please make sure to get a hold of me and let me know so I can give you some help. But until next time, have a good day.